So here we're just naming the degree of each polynomial, and the way that you do this is that you identify the exponent, the highest exponent, or the sum of the exponents if there's multiple variables. So for number 9, the exponent that we see is a 3. So we say this has a degree of 3. Okay? And for number 12, because there are multiple variables in it, we essentially take the exponents, there's a 3 and there's an invisible 1 over the z, and we add them together. What's 3 plus 1? That's 4. So this has a degree of 4. Now, normally, for any constant, number 15, for any constant, you have a degree of 0 for a constant. But the rule is, and if you look in the lesson notes, you'll see this, the rule is that it has a degree of 0 if it is a non-zero. Is this non-zero? No, it's not. This is not a non-zero constant. It is 0. Okay, so what we say is that this has no degree because essentially there's nothing there. Okay, no degree. That's something that is just a very specific piece of information that you're going to have to know. But if it was anything else, if it was, for example, -7, you would say it would have a degree of 0. So having a degree of 0, or it could be like 988, that's a constant, right? What's the degree? It has a degree of 0. So notice that having a degree of 0 is different than not having a degree at all. Okay, these two constants, these two non-zero constants, they do have a degree that we can call them. They have degree 0. But we can't say that 0 has degree 0. It's not, doesn't even have a degree of 0. It has no degree at all. Okay, so I'll erase this, but essentially that's the bit. If it is a constant that is not 0, we'd say it has degree 0. And if it is 0, we'd say it just doesn't even have a degree at all. There's no description of that.